Okay, class, on to part 2 of reviewing inequalities. This time we're going to be solving inequalities. And one thing you need to know about solving inequalities is it is almost exactly like solving equations. One difference is you have to know that if you're going to multiply or divide by a negative, you have to flip the sign. Once again, if you're going to multiply or divide by a negative, you're going to flip the sign. So let's get going on these two. This will be my first problem over here. And in number 1, I'm going to have to deal with this 2/3. That's next to the x. It's multiplying the x. I'm going to have to deal with the negative 7. That 7 is being subtracted. I want to get rid of that first. So I'm going to add 7 to both sides. Adding 7 does not flip the sign. The rule is if I multiply or divide by a negative, I flip the sign. So there's a 30. Bring down the inequality sign, and this should read, okay, lost some stuff there, and this should read 2/3 x is greater than 30. Now I could get rid of the 2/3 in 2 steps. I could multiply by 3 perhaps and then divide by 2, or I could do this all in one step. Remember reciprocal. If you flip the fraction, you are taking the reciprocal. And if I multiply a fraction by its reciprocal, I get 1. 3 times 2 is 6. 2 times 3 is 6. That's 6 divided by 6. And that's 1x, or x. And the sign still doesn't flip. I multiplied by a positive. So I can do 30 divided by 2, and that's going to be 15. And 15 times 3 is 45. So if I were graphing this, and I know it does not say to graph it, so I'm just kind of adding that in because we did it last time and it's a nice review. If I were to graph this, then I would have an open dot, the non-inclusive sign, and my boundary point would be 45, and its x is greater than 45, so everything that goes to the right. So here's my graph. And circle our answer. And move on. In this problem, we'll call it problem number 2, I will end up flipping the sign. I will start this equation by subtracting 6 from both sides. Now subtract 6 because you look at the sign in front of the 6, and there isn't one. That means that by default it is a positive 6. So subtract 6 to cancel it out. I need to bring down a negative. It was a minus, but now that this is gone, this would read negative. So negative 4x is less than or equal to 10 minus 6 is 4. So the first step I did not reciprocate. My first step I did not flip the sign, but in this step I will. Negative 4 is multiplying the x. We want to divide by negative 4. Negative 4 divided by negative 4 is 1, so that leaves me 1x or x. And on this side, a positive divided by a negative is a negative, so negative 1. I divided by a negative, the sign flips. So if I were to graph this, it would be the solid dot because it has the inclusive equals. The boundary point is negative 1, and I want to graph all things that are greater than negative 1. So once again, it will go to the right. Now we're going to solve a compound inequality. Remember that compound inequalities are inequalities that have either an or an and. We're just going to treat these as if they're two separate problems and then logically try to combine them. This one, subtract 1 from both sides, and I have a negative x is less than or equal to a positive 5. Divide both sides by a negative 1, or multiply both sides by a negative 1. Either one will do the same thing. Multiplying and dividing by a negative will flip the sign. 5 divided by a negative 1 is negative 5, and negative x divided by a negative 1 is x. So part of my answer will be x is greater than or equal to negative 5. I'm going to bring down or. This side, this part of the compound inequality, the x minus 4, less than or equal to negative 9. We're going to add 4 to both sides. X is less than or equal to negative 5. Oh, nothing else to do with that. That is as solved as it gets. So I'm just going to bring that down to this level. So take a look at all of the answer at once instead of having to circle 2 parts of it. So here I have what looks to be my answer. And you want to think of a number that is either greater than or equal to negative 5 or less than or equal to negative 5. Go ahead, in your mind, think of a number that is either greater than or equal to negative 5 or less than or equal to negative 5. Hopefully everybody could think of one, because no matter what number you thought of, it works. Here's a fancy little letter that gives me the answer. This means the set of all real numbers. Any number will do. All numbers meet that condition. So here's a picture of what the graph would look like. I wouldn't have any boundary point because it doesn't really have a boundary point. The negative 5 would be in there somewhere, but I don't care where. This would be a picture of the number line, but nice and solid. All real numbers. That's my real answer right there. All real numbers. That was kind of a fancy answer. Okay, now we're going to try this. Now, this is not a compound inequality. It's just a long inequality to solve. So we are going to take this number right here. This looks like a negative, but we might think of it as a negative 1. I made it yellow because we don't really need to see that negative 1. Just a negative will do. And I'm going to distribute that negative 1. So I will get negative 1 times 1 is negative 1. Negative 1 times negative 8n is positive 8n. Bring down the inequality sign. On this side, distribute the negative 5 to both of the terms, and I will get negative 20 minus 10n. And we stop the distribution at this parenthesis. Begin it here, end it there. So we just bring down the plus 1. Now, there are like terms, negative 20 and positive 1. Remember to include the negative in front of the 20. Negative 20 plus 1 is negative 19. Bring down all the rest. Negative 10n. Bring this down. Now it's time to take inverse operations, and I'm going to do what I usually do, and that is, let's try and get the variables, the terms with the variables, let's try to get them to be positive. So I will add 10n to both sides. And I have negative 1 plus 18n is greater than negative 19. Then I will add 1 to both sides. Negative 19 plus 1 is negative 18. And then bring down the 18n. And finally, divide both sides by 18. The sign will not flip. I didn't divide by a negative. And I get n is greater than negative 1. Didn't mean to put that dot there. N is greater than negative 1. That's my answer. If I were to graph it, it would be a open dot, because it's the non-inclusive. It doesn't have an equal sign. I would have negative 1 as the boundary line, and I want all things greater. So third time out of 3, it goes to the right. Okay, guys, that is enough examples for me showing you how to do this. Now it's time for you to go practice.